Let's try to illustrate the concept of a feature vector. X is x1, x2, ellipses until xd. So we can visualize it as a pointer in a d-dimensional space, where each coordinate of this point corresponds one of the components of the vector. However, for more practical visualization, we will limit this into 3 dimensions, as visualizing a higher dimensions directly is not feasible. Let me plot a point in 3-dimensional space to represent a feature vector with 3 attributes. So this will help you to understand the general idea, which will extend into higher dimensions in similar manners. So this abstract beyond 3 dimensions. So I just visualize a 3-dimensional feature vector, which is x equals 4, 5, 6. And the magenta dots represent the origin 0, 0, 0, and the cyan dots represents the feature vectors x1, x2, x3, which is equals 4, 5, 6 in 3D space. And the yellow line extends from the origin to the feature vector, which illustrating the vector's direction and magnitude in the space, which is defined by these attributes. We are given a clustering problem here. Each example has d attributes with an example x, which is specified by a d-dimensional feature vectors. X is x sub 1, x sub 2, ellipses until x sub d. So let's formally define this clustering problem. The input is a set of n examples, and each example has a set of attributes which is in common with all of the other examples, though the attributes value may vary among the examples, right? So in our last clustering problem, clusters is n equals 49, which means we have 49 examples, and we have 48 state capitals plus the District of Columbia into k equals 4 clusters, and each example has 2 attributes, the latitude and the longitude of the capital. We just formally define a clustering problem where each example in the dataset has attributes common to others, but the values vary. So here, the clustering involves the capitals of the 48 contiguous states plus the District of Columbia. The latitude and longitude, according to this, we can group them into 4 clusters, which is just based on these geographical locations. Each capital city is represented as a point in this 2-dimensional space, where the axis corresponding to the latitude and the longitude, and each point has a feature vector, which is capital X equals to x sub 1 and x sub 2. Well, the x sub 1 is the latitude and x sub 2 is the longitude. This is the simplified diagram which illustrated the clustering of the US state capitals into 4 clusters. So based on the latitude and longitude, each point represents a capital. So we colored them according to the cluster it belongs to. The white crosses mark the centroid of the cluster. So the centroid is calculated as the mean of all the points assigned to that cluster, and the centroid acts as a representative of the cluster's location in this featured space. So the purpose of the centroid is to minimize the square distance between it and all points in its cluster, thereby optimizing the cohesion of the cluster. So this iterative relocation of these centroids is what drives the k-means algorithm towards a solution where the intra-cluster variance is minimized. So this visualization helps us to demonstrate how k-means clustering group the data points into the clusters that minimize the distances between the points and the same clusters and the cluster center, which optimizing the homogeneity with each group.